Good morning, everyone. Before we get started, I just want to let you know that tomorrow you'll have some time to review feedback from today's assignment and yesterday's assignment. And then there will be a few review problems, but I want to give people a chance to really make sure they understand what we've covered so far. So there won't be much new material tomorrow. If you're feeling really comfortable, there will be a few challenge problems for you to think about, and then hopefully everybody will be feeling pretty good. So if after today's lesson you feel really stuck, definitely send me an email. We can set up some time virtually or potentially in person tomorrow to make sure that you feel more comfortable. With that said, I'm going to introduce you to a few things. So you might have seen what's known as a binomial before, and same with a trinomial. So think of a binomial as an expression with two terms. So an example would just be 2x plus 4. It's an expression, there's no equal sign, and it's got two terms. That's it. With that in mind, I'm sure some of you can probably guess what a trinomial is. And that's really just an expression with three terms. I bring this one up because it's going to look a little bit different than some of the stuff you've seen previously. So in this case, I might give you something like 3x to the second power plus 5x plus 1. That has three terms in it. And so that is our trinomial. What we're going to get comfortable with today is making sure you understand what an exponent is. All right, but first let's look at how an exponent even comes about. So something like this, x plus 4 times x plus 3. So in case you need that reminder, remember when they're next to each other like this in parentheses, there's multiplication happening between them. All right. With that said, there's two ways you can think about this. When I'm multiplying two binomials, I want to multiply the first term here by the first in the other, and the first term times the second term in the other. And then same thing, second times first, second times second. So that gets a little bit confusing sometimes. Some of you might feel comfortable with that. Feel free to use that technique. Here's the way I think about it. I like to make what's known as an area model. So I make this box with 4 quadrants. X plus 4 is one of my terms. So I'm going to write x plus 4. One of my other terms is x plus 3. So I'm going to write x plus 3. All right, and all that happens here is x times x happens in this box. So x times x is x to the second power. This box is going to be x times positive 4. And I like to throw the little positive sign in just to remind myself. But x times positive 4 is positive 4x. All right, and this box is going to be x times positive 3. So once again, I'm going to do a little plus 3x. You'll understand why I'm doing this plus in the next problem. And then finally, this last quadrant is positive 3 times positive 4, which is positive 12. All right, so in my box now, I have an x squared, a positive 4x, a positive 3x, and a positive 12. So with that in mind, I'm just going to write those out in a line. So now I have x squared plus 4x plus 3x plus 12. And I'm sure you're noticing that there's an x and an x. And so 4x plus 3x is really just 7x. And x to the second power is a different represents a different quantity than x. And so these are not like terms. I cannot add something with an x squared to something with just an x. They have different exponents, therefore they're not like terms. So after multiplying, this is my final answer. So with that said, let's take a look at this example. So all the same rules apply. Technically, we're multiplying these two. And we're multiplying first and first, first and second, second and first, and second and second. This one, I think, offers kind of a unique situation because you'll probably notice that there's a negative in here. So I'm going to do 2x minus 5, and I'm going to do x plus 1. All right. So in this case, x times x would be x squared, but notice how I have this 2 in front. So 2x times x is just going to be 2x to the second power, or 2x squared. X times negative 5 is going to be negative 5x. 2x times positive 1 is going to be positive 2x. And positive 1 times negative 5 is going to be negative 5. So the reason I was throwing the pluses in on the previous problem is to help me remember that this is a positive, and so it's going to be added in my final string, whereas this one's going to be negative. So to illustrate what I mean, so now we have 2x squared, we have our minus 5x, we have our plus 2x, and then we have our minus 5. All right, and now you'll see we have our 2x squared. There's no like terms there, but there is a minus 5x plus a 2x. Those are my like terms. And so if I add negative 5x and 2x, I get negative 3x, and then I have this negative 5 left on the end. And that's it. So really, you're creating your box, which helps you figure out all the multiplication that's happening here. And then once you have all 4 terms, you can write them out in a string, and then you can simplify to get your final trinomial. All right. And then real quick, when I say evaluating binomials, here I'm giving you an expression, I'm giving you a value for x. So in this case, think about we've got x plus 4 times whatever x is plus 3. Well, we know that x equals 2. So 2 is going in my boxes. Now in this parenthesis, so remember parentheses are the first thing we attempt to simplify, I have 2 plus 4, which is 6. In here I have 2 plus 3, which is 5. Now I've simplified things in both my parentheses. Now I'm ready to multiply them. 6 times 5 is 30. And that's it. We've evaluated. All right, same thing over here. The only difference is we are going to have a slightly longer simplification happening here. So once again, I'm throwing in my boxes for x, and in this case, I'm saying x is negative 3. Notice how in this set of parentheses, there's some multiplication happening. So that's the first thing I got to take care of. So 2 times a negative 3 is going to be negative 6. We still have that minus 5 happening. No multiplication happening in this set of parentheses, so I can just do negative 3 plus 1, which is negative 2. All right. So in this case, I still have one more step. I got to simplify this set of parentheses. Negative 6 minus 5 gets more negative to negative 11. And now I've simplified everything in both sets of parentheses. Now I'm good to multiply them together. Negative 11 times negative 2 is 22. All right. So not the worst, not easy, but I think with practice we'll get good at it. Here's one thing I want to point out now. Notice how when I multiplied these binomials, I got these trinomials. And notice how I just reused those binomials for you to evaluate, and these are our two answers. Now I'm using these two trinomials, and I'm having you evaluate as the same, with the same two x values from the previous problem. I want to illustrate the fact that if I evaluate at the same value, I should get the same exact answer. So here I have x squared plus 7x plus 12. All right, so first let's make sure we realize that we're replacing x with a number. In this case, it's 2. All right. The big thing you need to know about the squared is that it really says take this number and multiply it by itself. So in other words, that 2 squared is really telling me to split that into this times itself. So this is really what I'm trying to evaluate. This is an unnecessary step. I'm just demonstrating that this is what this actually means. And now I'm ready to deal with all my multiplication because there's no parentheses. So 2 times 2 is 4, plus 7 times 2 is going to be 14, plus 12, and I get 30. Same exact answer as above. All right, so same thing here. This really means 2 times something squared minus 3 times something minus 5. This one gets a little bit trickier. So here I'm saying x should be negative 3. So negative 3 is going in here, negative 3 is going in here. All right, once again, this negative 3 to the second power really tells me I'm doing negative 3 times itself. So in other words, doing negative 3 times negative 3. There's a lot of 3's going on here. All right, so now I'm just rewriting everything. And so 2 times negative 3 times negative 3, well, that's going to be negative 6 times negative 3. Negative times a negative is going to be positive. Here, remember when I have minus, this is going to be a negative 3 times a negative 3. It's going to be plus 9. And then I have this minus 5 on the end. All right, 18 plus 9 is 27. Minus 5 is 22. Once again, notice how my answers are the same. So to sum it all up, because this times this is this trinomial, when we evaluate at the same exact number, we should get the same exact answers. Same thing here. This times this is this trinomial. So when we evaluate them both at the same number, we get the same exact final answers. All right. So once again, give this your best shot. If you get stuck, do not hesitate to reach out to me. I'm happy to answer questions and set up a meeting time if you need it. With that said, good luck.